project titled A Common Method of Share Python Projects in Image Secret Sharing. Now coming to the introduction part, image secret sharing is a cryptographic technique used to safeguard sensitive images by dividing them into multiple shares in such a way that the original image can be reconstructed when a sufficient number of shares are combined. In the context of Python projects, sharing code securely is crucial for collaborative development and intellectual property protection. A common method of share Python projects in image secret sharing explores a novel approach to share Python projects using image secret sharing techniques. This method aims to provide an extra layer of security and confidentiality for Python project code, ensuring that only authorized individuals can access and reconstruct the complete code base. So our main objective for this project is to enhance the security of Python projects during sharing and distribution. By leveraging image secret sharing, the project's source code is divided into several shares, each represented by a unique image. These images are seemingly innocuous and can be shared through various channels such as emails or cloud storage. However, when a sufficient number of shares are combined, the complete Python project can be reconstructed, ensuring that only those with access to the required shares can recover the original code. This approach aims to protect intellectual property rights, prevent unauthorized access, and enable secure collaboration among team members while sharing Python projects. The specific objectives of this method include confidentiality. So here, confidentiality, ensuring that the shared Python code remains confidential and accessible only to authorized individuals or recipients. Ease of implementation, striving for a method that is practical and easy to implement for developers. Robustness against attack, ensuring that the methods remains resilient against various attacks, including brute force attempts to reconstruct the code using insufficient or incorrect shares. Now coming to the requirements part, there are two types of requirements, that are hardware requirements and software requirements. So in hardware requirement, first, operating system, that is Windows only, processor i5 and above, minimum 4 GB of RAM is required, hard disk 20 GB and above is required. Software requirement, that is Python IDEL 3.7 version is required. Now coming to the methodology part, first we have K-share value. The term K-share value typically refers to the number of shares required to reconstruct a secret using a secret sharing scheme. In secret sharing, a secret is divided into multiple shares, and a certain number of shares, denoted as K, are needed to reconstruct the original secret. For example, if the secret is divided into 5 shares and K is equals to 3, then any combination of 3 shares out of the 5 will allow you to reconstruct the original secret. However, with less than 3 shares, the secret remains unrecoverable. Second, N-share value. The N-share value refers to the total number of shares generated when using a secret sharing algorithm. In the context of secret sharing, the secret is divided into N shares, and these shares are distributed among different parties or stored in different locations. As mentioned earlier, the original secret can be reconstructed only when the number of shares used K is met. Therefore, N should be greater than or equal to K to ensure that the secret can be successfully reconstructed. Third, upload authentication image. This likely refers to a step in a specific system or application where a user is required to upload an authentication image. This image could be used as a form of biometric authentication or an additional security measure to verify the user's identity. The system may prompt the user to upload a photo, scan, or any image that has been previously associated with their account for verification purpose. Fourth, upload secret image. Similar to the previous point, upload secret image implies a user action in which they upload a specific image designated as their secret image. This image might be used for various purposes such as generating a cryptographic key or a unique identifier associated with the user. The secret image could also be a part of the image secret sharing algorithm mentioned in point 5. Fifth, encrypt using image secret sharing algorithm. In the context of image secret sharing algorithm, this refers to the process of encrypting a secret using a technique that involves images and their shares. The algorithm likely combines the secret image uploaded by the user, that is point O, with other images or uses it as a key to create shares. These shares are distributed or stored separately, and the original secret can be reconstructed when a sufficient number of shares K are combined as mentioned in points 1 and 2. 6. Decrypt using image secret sharing algorithm. This step involves the reverse process of point 5. Decryption in an image secret sharing algorithm means reconstructing the original secret using the shares generated during encryption. When the required number of shares, that is K, is gathered, the algorithm can use them along with the secret image or other information to decrypt and reveal the original secret. 7. Historical graph. A historical graph is a graphical representation that displays the distribution of data in the form of bars. It is commonly used to represent the frequency or count of different values within a dataset. In the context of images, a histogram typically represents the intensity levels of pixels in the image. For an example, in a grayscale image, the x-axis may represent pixel intensity levels ranging from 0 to 255, and the y-axis shows the frequency or number of pixels having each intensity level. Histograms can be useful for understanding the contrast, brightness, and overall distribution of pixel intensities in an image. 8. Encryption time graph. An encryption time graph shows the relationship between the encryption processes, execution time, and various factors such as the size of the data being encrypted or the complexity of the encryption algorithm used. It provides valuable insights into how encryption time changes with different parameters. 9. Exit. The exit option likely indicates a command or button that allows the user to exit or close the current application program or menu. Choosing this option would lead the user to terminate the current process and return to the main system or desktop interface. Now coming to the execution part. To execute the project, first we need to open the code folder. So here we have 3 folders, that is auth images, secret images, and shares. So in auth images, we have some images. In secret images, we have secret images. And in shares folder, we have some of the images. Here decrypt and sc are the images. And this secret sharing is the Python file which is containing the Python script in it. So here, this is the run.bat file. Instead of executing the program in command line interface, we created Windows bat file to execute the project. Now to run the project, double click on run.bat file to execute the project. This is the graphical user interface with this we are interacting with the program. Now click on upload authentication image over here. Choose any one of the image from this and click on open. So now click on upload secret image button to upload secret image. Here I am choosing this image. Now click on encrypt using image secret sharing algorithm button to hide secret image and then encrypt using XOR, LPS and get below out. So you can see the output over here. So first image is the authentication image and the second is the secret image, and 3 to 6 are the generated encrypted shares, and to extract hidden secret image we need to gather all shares. Now click on decrypt using image secret sharing algorithm button to extract hidden orange secret image. So here in this screen, hidden secret image extracted by gathering all encrypted shared, and similarly you can upload images and then encrypt and decrypt and extract hidden secret images. Now click on histogram graph button to get the graph. So here in this screen, for each share from SC1 to SC2 and D, we can see histogram graph, and all graph contain dense values, so image is more secured. And now click on encryption time graph button to get the graph. Here in this graph, x-axis represents computation type like encryption and decryption, and y-axis represents execution time, and IS is taking more time for encryption compared to decryption. Now here we can exit for our project. Now coming to the conclusion part. In conclusion, a common method of share Python projects in image secret sharing proposes a creative and effective solution for securely sharing Python projects. By employing image secret sharing techniques, the method divides the Python code base into multiple shares disguised as harmless images. These shares can be distributed through regular channels without raising suspicion about the nature of the content. The primary advantage of this approach lies in its ability to protect sensitive Python code from unauthorized access. Even if an individual intercepts one or more of a few shares, they would be useless without the minimum required threshold of shares to reconstruct the complete project. This not only safeguards the intellectual property of the developers but also encourages collaborative development in a secure environment.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.